I'm Fred Martial, the EMEA Sales Manager for VTI Instrument, and we are going today to discuss about driverless application. So the first thing is I want to welcome everyone and to thank you for joining this webinar. This will be held by Yves Kameni, or Field Application Engineer for VTI in EMEA, and I'm going to give him the lead now. So thank you, and feel free to ask your question. We will have Q&A question at the end of this session. Thank you.
Thank you, Fred. Hello, everyone. Welcome to the webinar. As Fred introduced me, I'm Yves Kameni, Senior Field Application Engineer for VTI Instrument, based in Germany, in Meerbusch exactly, where our service center for calibration repair is based. So today I will present VTI approach on the driverless application for data acquisition instrument. So this is the easiest method and a method really to help you to configure, control the instrument without having the need to install drivers. So I will share my screen. All right. I hope everyone can see my screen now.
We can, yes.
Let me make it full screen. All right. So
that's okay.
That's okay now? Great. So let's start. On the agenda that I prepared today, we will go through a quick overview of a classic test system development, why IoT in the industry, then VTI instrument approach to driverless control, our turnkey solution that we offer for customer. There will be a hands-on, so a demonstration, and at the end, a conclusion and Q&A question, as Fred mentioned. So feel free to use the chat to post your question, and we will come back at the end and answer, hopefully, all of them. So let's start with the first topic. It's an overall overview, giving you an overall idea of designing or building a test system for a large or small system that has evolved from a manual test system to an automated test system over the course of the year. So as we can see in the picture on the right side, so there are some factors that has to be considered now this day. So there's the safety aspect, the interface and connectivity, the switching and signal routing, data acquisition and signal generation, and last but not least, software. So we will focus during this presentation on the evolution of data acquisition system, so DAC, and software. In case of data acquisition system, the main purpose is to capture critical parameters like voltage, strain gauge, also strength, temperature, pressure, and more. So it's here important that the selection of the right one is mostly driven by factors such as signal conditioning, measurement accuracy, isolation, channel density, sometimes on form factor or modularity of the system, depending on customer requirements. The next important aspect after choosing the right data acquisition system is the software and communication standard to configure and control the instruments. As now, most of test and measurement manufacturers often offer turnkey software solution with their hardware. However, some don't cover the complete range of the most standards below. So they are listed below, like LXI, PXI, PTP, and EVI. And it will become a bigger issue for future expansion or upgrade of test benches. Therefore, selecting data acquisition hardware that are all compliant to the same industry standard becomes really, really important. And as we know, software is key for test system automation. So there is various programming language used now these days, as we can see in the below graph, highlighting the evolution over the time. So from C++, MATLAB, LabVIEW in the 80s, then Python, HTML, JavaScript in the 90s, now Node-RED in the early 2016. And not forgetting the costs, definitely, not forgetting, and it's important to really understand that a selection is often based of the level of performance, usability, reliability, sometimes security, depending on which area the application is running, if it's in a defense, aerospace and defense area, or in an automotive, or at the university, or research and development. And most importantly, compatibility, and not forgetting as well the cost, efficiency, and integration time. So now that we hopefully have a better understanding of the complexity involved in choosing the right data acquisition system and software solution, let's talk about the add value of IoT for test and measurement system or the community of a whole. So first, why IoT in the industry? So first, because the ecosystem is driven by real-time data collected by a wide range of IoT sensors. Secondly, the age of computing, which allows now these days to process data faster with less latency, better performance and security, and more smart devices with network gateway. And that can be, of course, controlled without drivers. In the next slide, I listed some keynotes of programming hardware over the evolution of the industry, especially between the industry 3.0, 4.0, and further. So now we're on the industry 5.0. So some of them are in the early 2000s, the introduction of common standards such as EVI, LXI, PXI, enable users to create drivers to control instruments from different manufacturers, which is still the case. With the growth in the popularity of Linux OS, many traditional Windows APIs were ported to Linux. And by the way, it's what also we want to offer and keep offering for our legacy and new customer. The next point, the third point, around the same time, proprietary programming languages started to decline with the rise in popularity of free open source community-driven programming language and environments. So IoT taking the lead, and as today, over 80% of new devices will be IoT, like our smartphone, computer, and other smart devices that we can have at home. So it has the great potential to advance and improve our life with smart communications and great interconnect abilities. So as we understand the importance of IoT, let's now talk about VTI approach to driverless control. First, the first question that comes in your mind, or every person, is like, why? The main reason, as already mentioned earlier, is because IoT is a multi-platform adoption and really driven by default driverless. And even now, a lot of customers are facing problem with installation, compatibility of drivers on Windows and Linux PC. So that's why VTI choose to go this way. And we select the REST standards, which is a representational state transferred, and it is quite simple because it goes over HTTP protocol that every one of us knows, hopefully. So HTTP really is its simplest way to communicate it now this day with smart instrument. And the reason of them are because HTTP has become the de facto standard for accessing resources and communicating over the Ethernet. It's using really simple protocol like GET, PUT, and POST to communicate it with any resources on the network. It uses JavaScript object notation as a data interface, as an interchange, sorry, to it's really flexible and easy to modify and adapt with other data type like XML and more. So here's an illustration of an REST API with VTI instruments as a server communicating to the client and host PC through HTTP methods. So the application is OS independent, so it can run with any OS and use any programming languages. All you need is the appropriate REST APIs for your software environment. So now, currently, VTI developed REST API for Python's language and Node-RED. So the demonstration later will be on Node-RED. So we'll focus on Node-RED as it is more a visual way to configure an instrument, and it's really often used in industrial automation. But the same application really can be done in Python or any other language. So Node-RED is a free open source programming environment which require only a web browser. So all the configuration that we do later will be through a web browser. So this environment allows complete automation and acquisition of multiple vendors, instruments, and software, and many other devices. So basically, VTI REST API is a set of nodes that I will show you later, describing each high-level functions for controlling the instrument. So no programming experience is really required, so everyone can really jump easier to start configuring one instrument to multiple instruments. So it's really easy to build your application connecting multiple vendors. It can be data acquisition, it can be PLC, it can be smart devices. And so what you only require is an Ethernet connection, and you are really good to go. So on top of that, we can add security in forms of HTTPS with password access to secure your software programming environment. So Node-RED, what it is, how is it, how it look like? It's really a simple way to configure an instrument. So it's similar like we often say LabVIEW. It has a background block, as you can see here on the left, and it has a front panel, so that means a dashboard to display and control the equipment. So I think I talked a lot, so let's jump into the presentation, as well as demonstration, and to have a better idea of what it's Node-RED capable. But before we start, I just want to illustrate it the driverless API architecture, which is supported by our X400 instrument series on LXI platform and on PXI platform with our digitizer. So on my desk currently, I have one X1401 for high precise temperature acquisition, where I connect one thermocouple from type K. And the instrument is powered over Ethernet with a PoE switch, so power over Ethernet switch, and a LAN connection connected directly to my Windows 11 PC. So let's start with the demonstration. So I will stop the presentation shortly. And yeah, I already installed Node-RED on my PC. So currently, as you can see, I'm using LXI Discovery to check if there's any instrument in the network. And as you can see, I have one X1401 in the network. And to start, so let's say to launch Node-RED, I required a command prompt. So in the command prompt, we'll type node -red, and it will load the Node-RED environment. So after the loading is complete, I can reach the Node-RED workspace or editor through the server, the following server. So here's an IP address. So I will click on it, and it will open in Node-RED interfaces. So basically, I will try first to give you an overall idea of how Node-RED look like. So on the left, we have what we call nodes. It can be modules in other language like Python's, so that the user can install. So there are some common nodes. For example, inject. So you can inject a value. It can be a flow. It can be a boolean to a node or to an API interfaces to communicate it and to set some value or get some value. We have some functions nodes and some network nodes. In the network nodes, here is the VTI REST API that I installed. And as you can see in the middle of Node-RED, so my workspace, I use them for configuring my flow. There are other nodes that can be interesting that can be used for application for, like, for example, storage nodes, local storage, or remote nodes for access for remote access. And one important node is the dashboard node. So where you have the capability, where you have the option to add dashboard nodes for displaying or controlling the instrument. So now on the middle, I have my flow, so my configuration, where I will now build my diagram. So the idea is really to drag and drop nodes and link them all together. So for this example I explained earlier, I want to acquire with the X1401 one thermocouple type key with the instrument. So for this purpose, the first action I need to do is to establish a connection with the X1401. So the connection is a TCP connection, and it will be done through the port 99010, and this is the host name, so let's say the resource name or ID that I will address for the connection. So after that, I will start configuring my instrument. So the first step, first of all, is to configure the channel layer. So as I just require one channel, the first step is to disable all other channels. So I define a node with the value false that I will inject in the following VTI REST API nodes. And in the VTI API nodes, here are some parameters that I can define. First of all, there's some generic name for just representation. The most important part, or the most important parameters, let's say like that, is the host name, as already mentioned, the instance, which is instance 0 in our case, and the path. The path is really, you can view it as a tree. So on the top levels, the digitizer. Then under the digitizer, I have different layer. So on the layer that I want to configure now is the layer channels. And under the layer channels, I want to go on the bottom of the layer to all and enable, and I will put a value false to disable all the channel. So now let's see. Okay, I'm connected. So the next step now is to enable one channel. So I will now, same principle. It's really the same principle as the first I explained previously. So now I will set a value true to set up the channel 1 to be enabled. Then I will set the function which is a temperature function, then the thermocouple type I want to acquire, type K, and the sampling rate. So after that, I will now define my arm on trigger configuration. This is another layer. In my case, I only want to configure the record per size I want to have, which is an integer. It can be 0, 1, or 2, or more depending on number of records you want to write on the FIFO of the instrument. So I didn't define all the parameters because I left it as default. So that means as soon as I will start to initiate the instrument, the arm, the trigger, it's done immediately. So that's why I don't. I didn't add those parameters in my flow, and but it can be done. It can be easily done. So now the next step is the instrument and measurement control. For that, I define some nodes for reset, enable streaming, initiate the instrument, which is the most important one, to read the data and to abort, and also some error queuing. So now we are moving to the right side. So all of them are connected to a kind of message console. So as you can see on the left side, there's a debug console, a debug windows, where all the communication will be logged. So below I define two functions where I'm extracting some data and writing them first on the CSV. So this will be writing nodes to write the value, so the timestamp and the data in a CSV format. And the second function is really extract only the channel 1. So you have a possibility to filter, let's say, to code on the message that you are receiving. And I'm really trying to filter out the data with the tag channel 1 in the data payload that I'm receiving, and extract them and monitor them in different ways. So I use here two ways to monitor the data. So for that, I selected two dashboard nodes, which is a real-time data representation node and a George node. So this is basically the main idea how to configure your nodes. And as I said, as soon that you add your nodes or drag and drop, do the modification, add some code for extracting data and so on, you need to connect them all together. And after connect them all together, you need then at the end to deploy. Let's, for example, say I'm changing the value from the sample rate to 10 hertz. So here, there's the deploy button. So I need to then I click on deploy. Then you will see that there's some kind of check that will be done in the code. So and there are some error, but this is something will not have an impact, I think, at all on the demonstration. So that's it basically. I also add a kind of remote access node to have a remote access to this configuration, to this flow. So I currently define it or configure it on my phone. So unfortunately, I cannot share it on real time, but I did a screenshot that I can share later with you. So after configuring all my nodes, connecting or link them all together, so I can now go to the dashboard view. So the dashboard view, completely here on the right side, there's a button here going down, then here dashboard. And there's a link here. When I click on it, I will have now access to the front panel or dashboard, as I say. And there are some dashboard nodes, as I mentioned, that I define it. So those nodes here on the right side are some instrument nodes that I defined for controlling the instrument. So if I try to go back on the, or let me just, I try to go back. Let me just go back on the flow, on the block diagram. Here you can see that I defined 4 dashboard nodes for reset, initiate, read, and abort. And this is really the representation here. So let's now assume that I inject now properly all those value. So let's see now. So enable has been done. Now the function temp has been successfully injected. Then the type key has been successfully injected. And also the sampling rate. So after that, we can go back now to the dashboard and now try to initiate the instrument. You need to keep in mind, you can still go back on the block diagram to check if every apply changes has been successfully done. So now I will try to see to read. So currently it's not reading. So let me just check. There is an error, probably with the connection of the instrument. So I will just verify that the connection is fine. So I still have access to the software front panel of the instrument. Just go in the software front panel setting and see if I can have access to it. So I can see here, okay, it has not been done. Let me just abort. So it has been done, not apply, because the instrument was already doing some measurements. So I will just go back in Node-RED and now try to do the same procedure again, configure each layer. So now I enable channel 1. Take a little bit time. Then temperature, type K. Let me just see. Okay, now I can verify if my configuration has been properly done. If I go back to the software front panel, try to refresh, and let's see. Yeah, we can see that all the changes that I have done through Node-RED has been applied. So you can see all the channel has been disabled. I only have channel 1, which is enabled, temperature function, and type key. So now let's try to go back to our dashboard, try to initiate instrument, and read the measurement. Seems like, yeah, now we can read the measurement, as you can see. So I'm just measuring 1 point at time. I don't really streaming the data. So I'm just measuring 1 point. So doing some motion over here. So, and that's mainly the principle. So it didn't work as expected at the first time, but it's really a good example to show that if something is not really working at the first end, you can still have the option to verify if your configuration is properly done via the software front panel. So maybe something that happened during the booting of the instrument when I tried to verify the configuration at the beginning before the start of the webinar that I maybe messed up. But it was a good live example to really use the software front panel to really verify in general, not only in this type of application, in general to verify if every change that you are you're applying on the driver or the REST API interfaces is really properly applied on the instrument. So yeah, so this is really exactly the demonstration or the idea behind Node-RED. And as I said, I have the same access. I have access to this interface via my phone, and I mentioned I have quick picture of my setup currently. So this is how it looks like on my desk, and where I can also, from anywhere, I just need to have an Ethernet access, currently on the VLAN access, where I have an Ethernet access, so I can have access to Node-RED, and I can control the instrument from home or for wherever I want. Yeah, so this was the demonstration. I hope it was interesting, and let's now jump back to the presentation to conclude this webinar. So, okay, so I will share it back. So, and let's go back to the latest slide. So, in terms of conclusion, what we can really recall from this webinar is that really RESTful is it's really developer friendly. It's scalable, flexible, easy to understand, and easy to develop. And platform independent. The driverless RESTful HTTP should be seen as a tool making it easier to integrate data acquisition needs into a world dominated by IoT, such as smartphones or other portable devices that can be used with any programming languages and OS. And VTI, REST API, and Node-RED nodes make it easier to prototype developed applications that connect the physical world to cloud applications. And that's the very definition of IoT. So these are really the three key nodes from my point of view, and in general that we can recall from this webinar. And I hope it was an interesting one, and that you learned something new that can be useful for your application or future application.